All right, class, so this is an ALEKS topic that's called calculating the composition of a buffer of a given pH. And this is a pretty good question. It's just a simple buffer question. So whenever we see the word buffer, I think the first thing that I would sort of keep in mind is the Henderson-Hasselbalch equation. pH is equal to the pKa plus the log of the concentration of the base. That's the weak conjugate base over the acid. So this is going to definitely play a role in this problem. And I notice that I've given a Kb here, so I know that I'm going to want to convert that to a Ka, simply because I've got a Ka in my Henderson-Hasselbalch equation. So I'll have this Ka times Kb equals Kw equation in the back of my mind as well. And let's sort of start breaking it down. The first thing it says is that we're given 125 milliliters of 1.7 molar pyridine. Pyridine is going to be my weak base. And so it says pyridine is a weak base. It's giving me the Kb. And then I'm going to add this C5H5NHBr. So this is really my source of acid. So C5H5NH plus, right, that is what this would break into, this cation and then the Br minus. So this is really my source of my acid. Should the student dissolve in my pyridine solution to turn it into buffer with pH is equal to 4.86. So this is my target pH. So that's what's going to be plugged in here for my pH, 4.86. It's going to equal the pKa. Now to find the pKa, that's going to be the negative log of the Ka. So to find the Ka, I'm going to take, my Kw is 1 times 10 to the minus 14th, and I'm going to divide that by the Kb. So Ka, if we solve for that, it should equal 5.88 times 10 to the minus 6th. And then to find the pKa, I'm just going to take the minus log of the Ka. So if I do that, the pKa becomes 5.23. So then this is sort of the target pH. This is my pKa that I calculated from the information that was given. That's going to equal the plus the log of the concentration of base over the concentration of the acid. So at this point in time, what I'm doing is really just sort of orienting myself to the problem, figuring out what's given, figuring out sort of what is relevant. And like I said, the first thing that I'm going to write down is the Henderson-Hasselbalch equation. Then I'm going to recognize that I've given a Kb, but I really need a Ka. So I'm going to use this relationship here. Ka times Kb is equal to Kw. I know that Kw is 1 times 10 to the minus 14th. I can solve for my Ka, I can solve for my pKa, and I can get to this point here. So now from this point here, I recognize that I am given a molarity of pyridine. I've got 125 milliliters of this molar pyridine. And here I've got my concentrations. So this 1.7 molar, that's going to actually be my concentration for base. So I could rewrite this as 4.86 equals 5.23 plus the log of 1.70 over the log of my concentration of acid. So I'll just put that as parentheses acid. I can now solve this for the concentration of acid. So first thing I would do is I would subtract 5.23 from both sides. So you get minus 0.37 is equal to the log of 1.70 over that concentration of acid. Now I'm going to take 10 to the power of both sides. That's going to get rid of this log. So 10 to the power of both sides. That leaves me with 0.426 equals 1.70 over my concentration of acid. So really, we should be using brackets here, I think. So that concentration of acid, let's put some brackets in, I can solve for that. So now from this is telling me that my concentration of acid that I need to have in my solution is equal to 3.99 molar. So this calculation that I've done to this point is really telling me, well, if I have a ratio of 1.7 molar weak base to 3.99 molar weak acid, then I would have the pH that I'm shooting for, that target pH of 4.86. So from here, what I'm going to do is I'm going to take this, I'm going to multiply that by 0.125 liters. And the reason that I'm doing this, is going to equal 0.499 moles. Is because I want to figure out how many moles, and that way I can figure out what mass of this acid source I'm going to need to add in. So if this is my number of moles, then I need to convert that into grams. So 0.499 moles times, I calculated the molar mass for this C5H5NHBr as 160.01 grams per 1 mole. And that should equal 80 grams. I'm asked to run to 2 sig figs here. So that should be my answer for this problem, 80 grams. So let's recap real quick. The first thing that I'm reading, right, is that I am shooting for a given pH. So my pH 4.86, and I'm told that it's a buffer. So my Henderson-Hasselbalch equation, pH equals pKa plus log the concentration base over acid. That's my equation that I'm going to need to use. And I'm given a Kb value for this pyridine, weak base, weak acid, conjugate base, conjugate acid. But I know that I need to use the Ka because I'm using pKa here. So I've solved for the Ka, solved for the pKa. So I can plug my values in, and I'm also given my initial concentration of base. So that's 1.70. And I can use this Henderson-Hasselbalch equation to figure out that ratio essentially of acid to base, or base to acid, right? And solve for that concentration of acid. So this concentration of acid that I'm solving for, this is telling me if I make my solution that is that concentrated in acid in 125 milliliters, then I'll have the right pH. So this is my concentration, this is my volume, and it says that the volume doesn't change, so this is still my volume. So this is solving for the number of moles of acid that I would need to add in. So that number of moles is my moles of acid, and then this last calculation is just converting it from moles into grams, and this is my acid, so this is the molar mass that I would be using. Calculate that as 160 grams per mole, and that equals 80 grams. So if you put 80 grams of this acid into your pyridine solution, you would end up with a buffer, and that buffer should have a pH of 4.86.